How to find an exoplanet. Now you're probably saying, William, it can't possibly be that hard. How hard can it be? Very. While large Jupiter-sized planets give off a faint infrared glow, they are dwarfed in comparison to the amount of light that their parent stars give off, making them almost indistinguishable from their parent star. So needless to say, the only planets that have ever been discovered through direct observation are large Jupiter-sized planets, very far away from their stars, far enough away so that we can distinguish them from the star. So how have we discovered so many extrasolar planets? How are they not all just hidden? You're clearly not going to see them with a pair of binoculars, so how? Well, we can use indirect methods. As a planet transits in front of its star, the amount of light given off by that star is obscured by the planet, therefore lowering the amount of light that we're getting from that area of sky, and sometimes, if the planet is big enough, it'll be a noticeable difference. This isn't a perfect method though, for 3 reasons. The first reason is because even a planet that orbits about as close as the Earth takes a year to transit in front of its star, so we don't get many opportunities to measure a transit. Secondly, it has to be a noticeable difference, so the planet has to be very big. As you can probably tell, this method favors finding hot Jupiters, Jupiter-sized planets that orbit their star in 2 to 3 days, making them very easy to discover through this method. The third reason this is very hard is because in solar systems like this, the planet will never transit in front of its star, and we will never be able to see a transit, therefore never being able to discover the planet. And less than 1% of all planetary systems are like that. So how else do we do it? Well, there's the radial velocity method, which is another way of saying we measure how much the star wobbles. Basically, a planet exerts a certain amount of gravitational pull onto its star, making it wobble a little bit in the sky. Of course, a lot of the time, this is counteracted by the gravitational pull the star has on the planet, but it's still there, and we can measure that. Now, of course, again, this favors planets that are closer and bigger to their star, because they exert a bigger gravitational pull onto their star. But with these 2 methods and several others, we've been able to discover thousands of extrasolar planets orbiting other stars, resulting in an incredible 2,074. And with how indistinguishable these planets are from their stars, discovering 2,074 of them, I really gotta commend scientists on there. Applause for you. Our knowledge on extrasolar planets is now so extensive, we were able to map out a temperature graph on the planet HD 189733b. And although we do need better names and methods that do not favor hot Jupiters, making up the majority of all extrasolar planets that we know about, we are making our way to a more complete understanding of the planets in our galaxy. Until next time, this has been Science Freak Astronomy.